Here we have a sad math question. Okay, let's go with the question. -7 positive 2f equals to cg, and there is another equation 21g positive 21 equals to 6f negative 15g. If c is a constant and the system of equations shown above has infinitely many solutions, what is the value of c? Okay, the question clearly says a given system has infinitely many solutions. So whenever a system of two linear equations has infinitely many solutions, both the equations must be same. Okay, the first equation is already in simplified form, but the second equation is not in simplified form because we find the variable g on both sides of the equation, so it is not in completely simplified form. Okay, so we have to simplify the second equation and we have to get it exactly in the form of the first equation. So then we have to consider both the equations same because the system has infinitely many solutions. So when we consider both the equations as same, so then we'll have a chance to get the value of c. Okay, now our first work is to simplify the second equation. Okay, let me take the second equation over here. That is 21g positive 21 equals to 6f negative 15g. So, and also apart from simplification, we have to get the second equation in the form of the first equation. When I look at the first equation, I find constant and the variable f on the left side and g on the right side. Okay, anyway, so let's do the same thing over here. Let's try to keep the constant and f on the left side and g on the right side in the second equation. So for that, first I have to get rid of the g on the left side. So I subtract 21g from both sides. So when I subtract 21g from both sides, this positive 21g, negative 21g will cancel out. I get 21 equals to 6f. And when I combine negative 15g, negative 21g, it will be negative 36g. Okay, now I subtract 6f from both sides because I need the constant f on the left side. So let me subtract 6f from both sides. So this positive 6f, negative 6f will cancel out. I get 21 negative 6f equals to negative 36g. Okay, in the first equation, the constant is negative, but in the second equation, we got the constant and f on the left side, but the constant is positive. Okay, to make this constant 21 as negative, let's multiply both sides of this equation by -1. So -1 times 21, negative 6f equals to -1 times negative 36g. So let's distribute this -1 to this one and this one. I'll be getting negative 21. Negative 1 times 21 is negative 21, and negative times negative will become positive. 1 times 6f is 6f, and here negative times negative will become positive, and 1 times 36g is 36g. Okay, now we have the equation negative 21 positive 6f equals to 36g. Okay, everything 21, 6, 36, everything is a multiple of 3, so we can divide everything by 3. So let's divide each term by 3. So 3 goes into 3 one time, 3 goes into 21 7 times, and 3 goes into 3 one time, 3 goes into 6 twice, and 3 goes into 3 one time, 3 goes into 36 12. So I get -7 positive 2f equals to 12g. Now it is exactly in the form of the first equation. Okay, now let me take the first equation over here. -7 positive 2f equals to cg. Okay, now we have both the equations in the same form, and the system has infinite. Since the system has infinitely many solutions, both the equations must be same. Here, let's compare the corresponding terms: -7, positive 2f, positive 2f. At the place of c, what do we have over here? It's 12. Here, c is the coefficient of g, the first equation. In our the second equation, so what is the coefficient of g? It's 12. So at the place of c, we have 12. So the value of c is 12 in this given system of equations.